Hi, this is Pratik and welcome to Code by Pi. In this video lesson, we'll learn about three different tree traversals of a binary tree. And these traversals are Inorder Traversal, pre-order traversal, and post-order traversal. Now, unlike other data structures like linked list, stacks, and queues, all these data structures allow linear traversal. That is, they allow only one logical way to traverse them, that is linearly. But in tree, it gives you the opportunity to traverse it in different ways, three different ways, and these are in order, post order, and pre-order. And in fact, in order, post order, and pre-order are actually depth first traversal. That is, they allow you to go as deep as possible in that tree. So in this tutorial, we will be particularly learning about in-order traversal, and in the upcoming videos, I'm going to talk more about the other two traversals like pre-order traversal and post-order traversal. Now let's start with a very simple example that we are given this binary tree and we need to perform in-order traversal of this binary tree. Now in-order traversal follows a very simple rule, and the rule says that first traverse left, then print the root, and then traverse right. So first, this entire binary tree is taken into consideration, and this rule is applied on this binary tree, which means first we travel left. So here left means go to the left subtree, and when you move to the left subtree, you again need to apply the same rule. So the left subtree of this binary tree is this. Now we apply the same rule on this subtree, that is, move to its left, then print its root, and then go to its right subtree. So when you apply the same rule on this left subtree and you try to move to the left part of this left subtree, so there is no left subtree of this subtree. So the left and right part of this node is none and none. So it's same as, if you want to specify, it's not at all necessary to specify none and none, but just for understanding purpose, I'm writing a none and none. So left part is none and the right part is also none, and therefore this second node doesn't have any left and right subtree, which means you cannot move to its left part. Then the only thing left is to print its root. So 2 gets printed here, and then you try to move to the right part of this left subtree, but 2 again doesn't have right part. So in this case, you again cannot move to the right part of this subtree. So now you cannot move further down of this subtree. So when you cannot further move down of this subtree, you move to the upper tree. So the upper tree of this subtree was this, in which you had already traversed the left part of this upper subtree, which means now it's time to print the root of this upper subtree. So 1 gets printed here, and after 1 gets printed here, you try to travel the right part of this tree, and the right part of this tree is this, the node 3, which means you travel the right part and apply the same rule there also. So you try to move to the left, so 3 doesn't have a left, its left is none. Then you print the root is 3 itself, so 3 gets printed here, and then you cannot move further down to 3. So you again move back to the upper tree. So you again come back to the upper tree, and you see that you have already finished applying the rule on this upper tree, which means there's nothing left to be applied, which means we are finally done with traversing the entire binary tree. So this is how you actually do in-order traversal in a binary tree. So now let's suppose you are given another example, which is this. So I've added a few more nodes to the left and right of 2. So if I tell you to travel this binary tree in an in-order manner, then what we do is that first you move to the left subtree, and then you're going to apply the same rule, which means you again move to the left part of this left subtree, which is this. Then you again apply the same rule, but you find that the left part is none, which means now you have to print the root. So 4 gets printed. Again, you apply the same rule, and you have already done with the left, you are done with printing the root, and now it's time to go to the right. So 4 doesn't have a right because it's none. So since 4 doesn't have a right, which means you are done applying the rule for this innermost tree. So you move back to the upper tree, which is this tree, And in this tree, you since applied the rule of moving to the left part, which means you are done moving to the left part, which means it's time to print the root of this tree, which means 2 gets printed there. And after 2 gets printed, that's the root, which means now you try to traverse the right part. So the right part is this, and you apply the same rule here. You cannot move to the left because it is none, which means now you print the root, which is 5. Then try to move to the right, but the right is none, so you cannot move further down to 5, which means you again move to the upper tree, which is again this tree, which means in this tree, when you move back, you see that you have applied all the 3 sections of the rule, that is left, root, and right, which means you cannot no longer further apply the rule because you have finished applying the rule on this tree, which means now you move to this upper tree. Now in this upper tree, you have finished applying the left part of the rule, that is moved to the left, which means now it's time to print the root of this tree. So you print 1, and after printing 1, you try to move to the right part of this tree, just moving to 3, and when you move to this right subtree, you try to apply the same rule, that is left. So when you try to move to left, you see that it's none, so you cannot further move to left, which means now it's time to print the root of this right subtree. So 3 gets printed there. After 3 gets printed, you have to move to the right, but 3's right is again, which means you cannot move right of this subtree, which means you have basically finished applying the rule on this entire binary tree. So this is the final result that you should get, 42513, and this is the Inorder traversal of this binary tree. Now let's do the coding part. So first I'm going to define a class node, and in this class node I'm going to define a constructor, and this constructor will be basically responsible for creating the structure of the node. And here I pass the node data, which means I want to put in the data of that node, and I am putting the node data in a new variable called data, which I will reference as self.data, and I'm gonna set the left part of the node as none and the right part of the node as none as well. Now after creating the structure of the node, let's first make the binary tree first. So first I am gonna make an object of the class node, and I'm gonna name it as root, and I'm gonna pass the node data as well. So node data is gonna come here, which means the data part of the newly created node will be set as node data, and its left and right will be set as none. Now I will alter the left part of this node, and I will say that root dot left is node with data as 2, and the root dot right will have a node with data as 3. Similarly, the root I've done with root dot left and right, and then now I will say root dot left is equals to node with data as 4, and root dot left will have a node with data as 5. So binary tree similar to this. So moving forward, I am going to define a function called Inorder. So in this Inorder function, I'm going to pass the root as the parameter. We're going to know why. So first, I am going to say if root is true. So here you can also write that if root is not none. So both means the same. This is basically for checking whatever we are passing is actually a node and it is not none. Now remember the rule that first we have to go to the left subtree. So first I am going to say Inorder root dot left. So I'm going to recursively call this function and pass root dot left as the parameter, which means now from 1 we move to 2. And when we move to 2, again the same function is applied, because this Inorder root dot left, again the function we will rerun from the beginning, and we'll check if root. So here root will be root dot left. So if root dot left is not none, it will again recall the function. So after we have traversed the left part, we will print the root, and then we're gonna move to the right part. So now I am going to see if this works or not. So first I'm going to call this Inorder function in the main, and I'll pass the root as the parameter. So I'm going to save this and I'm going to run this. All right, so here we see So this is the resultant traversal 42513, and this is what we are supposed to get. So I hope that you understood this video. Like and share this video, subscribe to the channel, and thanks for watching.